Okay, we're live.
Uh,
Then please present
but
your work, Wolf.
no, it's not my work. It's our work. So I'm sharing my entire screen. I hope you can see it.
1 sec. It's not showing up on my sharing machine. I don't know why it wouldn't show up.
You have to press that.
But it's a non-video sharing version that I have to activate.
Oh,
Go ahead.
yeah. So we wanted to give an update on all the stuff that we're doing, and especially all the stuff that we're doing in the Conda ecosystem. And specifically, there is a process called Conda Enhancement Proposals. And Conda Enhancement Proposals are basically like sort of specifications that are written and then they are being voted on by the Conda governance steering council. So those SEPs, like we have a few open right now, and I wanted to present on them basically, so that people are in the loop. And one more thing that I put together this morning that I can quickly share is just to show sort of the breadth of what we're doing. We are currently still working very hard on Redla build, which is a replacement for Conda build. Pixie, which is kind of a replacement for Conda log, and a few of these tools. Pixie pack is something that our friends at Quanco are working on, which is a replacement for Conda pack. Redla can be thought of as a replacement for libmamba, pyretla, libconda, and that actually never really existed, but libmamba py is a nice Python library. And so Resolvo, you all know probably, and then there's a new thing that we just merged in Redla, actually, that's JS Redla. And that's pretty exciting because that can solve for packages in the browser or using WebAssembly. So we compiled Redla to WebAssembly through Rust, and there's one other cool use case, which is using it in the Renovate bot, because Renovate bot allows you, I don't know, like they have some infrastructure and they can run WebAssembly and JavaScript. And I'm also indicating a missing puzzle piece because we don't really have the equivalent to Conda at this point, but maybe there's something brewing. Okay. So let's get this out of the way and talk about some of the open SEPs that we have going. You can see in the repository of the SEPs, there's a nice table here actually. And a few of these SEPs are done by us already. So sharded Repodata and the recipe format are 3 SEPs that we've successfully gotten voted on and merged into the repository. There are you can take a look at them. They are basically just markdown documents and are talking about the things that we want to do or did. We also are usually the fastest in the Conda ecosystem to implement SEPs. So we have already shipped this SEP 20, which Isuru wrote about supporting ABI3 Python packages. And that's something that's since a few versions in Redla build, it's available. And actually, we're using that for pyretla builds so that we only have one build for all the Python versions, even though it contains compiled code. So yeah, these are the things that people are kicking off using Conda Enhancement Proposals. And now we're going to talk about the things that we are currently kicking off. There are a few that are still going around, and that would be great to be merged at some point to just standardize things in the Conda ecosystem more. So this one is not from us, but that's a SEP for specifying what the match spec actually is, because match specs are used for selecting packages, but no one really has kind of made a real specification out of them. they are sort of specified by code in the Python code of Conda. And obviously in Rattler, we've sort of emulated everything that we could emulate. And we're matching the Python code very, very well. But it's never been formally specified. And similar things are for environment YAML, which is also a file that Conda is using. And in Rattler, we also have support for reading it, but it's never been standardized. And so, like, the idea for SEPs is basically, one idea at least would be to standardize all the things that are there already. Instead of just having them standardized in code, we would also like to have them standardized as like actual specifications. So that would be great. But unfortunately, this process is pretty slow going. We'll see if that hopefully is going to become a little bit faster. And now some of the SEPs that we are excited about are these 4 SEPs that I wanted to talk about. And let's start with this one that Buzz opened in January, and we actually, so the truth is we are already shipping that. So it's basically standardizing what we already did. And the contents of the SEP is that we have sharded Repodata, and there is some metadata in packages that's called run exports, and that's needed and useful at build time. So at runtime for Conda or for Pixie, this doesn't really matter. But for Rattler build or Conda build, run exports matter a lot. Run exports basically, help in the build process to say like what dependencies do you need at runtime based on the stuff that you're doing or using at build time. And run exports have never sort of made it into the original repodata.json because they would add metadata into the JSON file that is not really necessary for most users. And the Repodata.json is already a very, very big file. It's like 200 megabytes for Conda Forge, and then compressed, it's like 40, 50 megabytes. So there was never really an incentive to add it because it would just make that big file even bigger. The idea now is, though, that since we have sharded Repodata, we can add more stuff in these individual shards. And run exports are very similar data-wise to the rest of the stuff that's in the shard already. Because in the shards, like we have just the metadata for one specific package name. So for NumPy, we would only have all the package records for NumPy. And adding run exports there doesn't really increase the size by a lot. I think Buzz made a little bit of benchmarking here. So like what I mentioned, the Repodata.json is a really large file. There's already a separate file that's called run exports.json, which is also pretty large. And then compressed, and this is also compressed. And I think based on this, we calculated, or Buzz calculated, that the size of the Repodata shards would increase by like maybe 5 or 6%. But the gain for us is that in Rattler build, we have all the data available immediately. And so when rendering recipes, it will be just super fast. And for Pixie build, it's also super important because we want to build packages with Pixie build for like cross-platform. We're solving them, we're locking them, and all these kind of things. And we need to know about the run exports to determine all the versions and everything. And so for our use cases, it's very important to have the run exports data available. And if we just stick them in the shards, everything is fine. It's completely backwards compatible as well. And so, yeah, that's basically what we're proposing here. Then one more addition, and this is just for like Conda power users, is you can patch Repodata.json using a specific like patch instructions file. And we also want to make it possible to patch run exports, which is something that has been explicitly forbidden in a different set beforehand. But now that we ship it as part of Repodata, we think it should also be possible to just patch it the same way that you patch everything else in Repodata.json. And so this particular SEP, we actually want to get to a vote today. Voting usually takes, I think, between 1 and 2 weeks. And then the rest of the process is usually that we have these PRs, and in the PRs is where the discussion happens. So if you're inclined in engaging more with the Conda community, you can just come here and discuss with us and figure out the evolution of Conda and the Conda standards and the Conda ecosystem. Now, I promised to talk about more SEPs because we have more open. I'm gonna talk about the cache key for V1 multi-output recipes now. So I don't know if you've used Rattler build or not, but we basically first came up with that new recipe format, which is now called the V1 recipe format. And again, sort of same story as many parts of the Conda ecosystem. The V0, the meta YAML format was never really like specified. It kind of just happened, like it was written in the Python code, and everybody uses it, etc. But no one really like sort of went back to the drawing board and tried to come up with a formal specification. And there was a lot of implicit behavior in the recipes, etc. And we've already tried a lot to clean it up in the V1 format. And the cache is like the next step for cleaning that up. We already have implemented in Rattler build, and you can use it with the -- experimental flag. But now we want to get rid of the experimental flag and formalize it, basically, which is the point of the SEP. And the idea of the cache is that so this is a feature that existed in Conda build, sort of, where you have multiple outputs and you have a top level build. And with the cache, we're trying to formalize this top level build. So before any of the outputs get created, we run the cache build, and then every output kind of starts from where the cache left off. You can define the sources for the cache. So that is usually the source for the package itself. Some requirements, for example, a lot of, like for some recipes, people run CMake and the CMake compilation in the cache. And then in the outputs, they maybe install the library, install the headers in a different output, and then they install some Python bindings in yet another output. So then you can basically you build it once and then you split it up into multiple packages, or you build it once and then you build some additional like Python bindings. So that's one of the use cases for the cache. And so those are two slightly different use cases, but they are very similar, and the big use cases for the cache. Splitting up packages and making them more modular and smaller is a big point of it. And for example, in this SEP, there was a lot of discussion about what do we do with the run exports, because this is all like very deep into the Conda sort of stack. But again, run exports sort of need to be attached to any of the outputs based on what you do in the cache. Like the compiler will have some run exports on the C++ runtimes, and those need to be available. Like those need to be there as dependencies in at least one of the outputs in a way. And so so this was a good discussion that we had in that in the PR, and we found a solution that is not written down here yet. But basically, the idea would be that inside of the cache there will be another key that will say attach run exports to, and then it will be a list of names for each of the output, and we'll put the run exports there. So one of the ways of using the cache is that you define a package then that will sort of refer back to the cache, which is not indicated here. And then you can select the files that you want. So you can have one package that has only the headers, one package that has only the library files, and so on. So that's like, we really want to get this done because this is one of the SEPs that is sort of asked for by the CondaForge community, and one of the requirements, at least for some of the CondaForge people, in order to make Rattler build, like move Rattler build closer to become the default in CondaForge. But yeah, we're making very good progress, and also the expansion in CondaForge is making very good progress as well. I think there's already over 700 recipes converted which is very cool to see. Now I'm gonna show two more CEPs that are maybe even more thrilling. This one is a big one. So we are proposing more new Repodata features and match spec features. So these two, they go hand in hand in this case, because we want to introduce three new features. So we want to have extra dependencies that you might already know from PyPI. So that the package can say, okay, I'm like a base package, and then if you want to use MySQL or SQL Alchemy on PyPI has different, I think, package optional dependencies that you can use with square brackets. So you can say you want SQL Alchemy and then with the MySQL packages. And then it will add like an additional dependency group to your installation with all the stuff that's required for MySQL. And so that's the extras use case that we would like to cover. So that you can say, okay, I want some package and then I want some extra dependencies. Then there's also another feature that's called conditional dependencies. So conditional dependencies are basically you have one no-arch package, but it requires something that on Windows, like a specific dependency. And with conditional dependencies, we can say on Windows, you need to add PyWin32 or something like this. And those two things, extras and conditional dependencies, is something that is already done in Conda Forge, but in a sort of bad way in that sense, because for each of them, we need to add additional package records or Repodata records into the Repodata, which blows up the Repodata without sort of giving us anything. So the way that extras are done today is that you would define multiple outputs. So you would have SQL Alchemy -MySQL, and that package would require sort of back. It will require back SQL Alchemy, and then the SQL Alchemy MySQL package would have all the MySQL dependencies. So that is one way to work around for the extras. For conditional, what people do is like they create the same no-arch package twice, but once with a -- Unix or _ Unix package in the run dependencies, and once with the _ Win package in the run dependencies. And that will sort of flip that. So it will either use the one package based on the virtual package requirement on Unix or Windows. And then the last thing that we are sort of pitching here is what we're calling flags. So that's for something like compiled packages. And the idea is to make it easier to select different variants of packages with different build time arguments. If you are deeper into Conda or Conda Forge, then you might know that you can select different BLAS implementations, or you can select different MPI implementations and things like that. But the way you do that is usually with some kind of like globbing on the build string, which is not very ergonomic and not very user friendly. And we want to like get rid of that and instead replace that with explicit flags, so that you can just use them as a filter or as a selector. And you could say something like foobar flags and then select release. And that would make sure that only packages are matched that include the release flag. And so the packages can just come up with their flags. And I think on the level of something like Conda Forge, or on the level of the distribution, one would standardize on some flags. Like, for example, the BLAS implementation and the whatever MPI implementation, they would standardize on certain specific flags. But yeah, I mean, this is kind of still in the figuring out phase. Just to give you an update on where we are with the implementations. So for extras, we have actually we merged the prototype implementation, or maybe even a little further than just the prototype, into Rattler. For conditional dependencies, we do have a prototype in Resolvo, and we are actually doing some work, or specifically Parser is doing some work on sort of putting both of these implementations into Resolvo so that it is very nice. That's ongoing. And for flags, I wrote a little prototype in Rattler. It's like pretty simple to implement actually, because we just need to sort of filter and match things, which we're already doing with match specs. So it's just the same thing. We can dive a little bit deeper how that would look like. So in the Repodata or in the recipe, you would define extras as like a key, like it would be a dictionary with a key and then additional match specs like this. And for conditional dependencies, our idea is that we would use a syntax like this. So you would say 6 and then semicolon space if, and then some condition. And this condition again would be like a match spec. So our initial implementation might only work with something like virtual packages as match specs, because they are very simple, obviously, to match, and you know that even before solving, you know which of these are true or false. Matching on any, like basically having the condition on any other package, that's a little more tricky. It can definitely be done, and we also sort of know how to do it. But yeah, we'll see like how we roll this out. And for flags, the idea would be that we have just direct string matching and maybe some other sort of matching, like mini matching syntax. So a matching syntax inside of the matching with match specs to select, unselect. So with this one would flip that and disallow any packages with that flag. Maybe that should be changed to be an exclamation mark instead. We could do with a question mark, so that if there is a package with a release flag, then we take it, and otherwise we just ignore this. Something like a starts with, so that you would take the GPU package, but you don't care whether it's CUDA or ROCm or something like this. For flags that would have like an integer after a colon or something like this, then we could also have like a little larger, smaller, or equals syntax, etc. So that's the idea. If you have any opinions on this, please let us know. The idea would be, in terms of rolling this out, would be to create a new V2 version of the Repodata that would be sort of served alongside the existing format. Any package that would make use of any of these features would probably only end up in the V2 Repodata. Yeah. So the rollout itself, it would be probably a very long process, especially for something like Conda Forge, just because we have no idea what the plan is of Conda itself and Conda Build, if they would ever support these things. For us, on top of our tooling, it would be a pretty nice and straightforward process, because we'll just have the feature in Resolvo, then we'll have the Rattler, and then we can sort of immediately get it done in Rattler Build and Pixie and any other tool that builds on Rattler. So we are super excited for that. And we're also super excited to move all of this forward, because that's just really a big step, I think, into the direction of making Conda packages more powerful and flexible and versatile, and that we can stop to rely on like weird build string globbing and things like that, and weird sort of workarounds to create conditional dependency packages, etc. And this one also for extras, we are super motivated, because it would help us to close the gap between PyPI and Conda, and there's always a bit of friction between those two, because we cannot exactly sort of represent what the PyPI package does in the Conda package, because we don't have these extra dependencies. And now, I've been talking for a long time, but I don't stop, because we have one more, which is the SigStore set. This one is pretty short, but I'll also give you a sneak peek of the feature. For that, I'll pull it up on a different screen. So we've been working on getting attestations into the... So SigStore attestations is a method to basically sign packages or add attestations to packages. And the attestation says like cryptographically says some things about your package, especially where it was built, who built it, etc., etc. And so far, our integration uses GitHub Actions and the GitHub Trusted Publisher, which we already put on our website, to store these attestations on our end. And now with this step, we would like to formalize what these attestations should look like for the Conda ecosystem and formalize this. And the idea is that this is just talking about SigStore. And I think like the main thing that we want to do in this step specifically is that we create this predicate type and then a predicate. And this predicate is very simple. It will only say like this is just a specification that we would like to publish on schemas.conda.org, which by the way exists since like a week. And the predicate would only say one thing, which is what the target channel is of that package that you uploaded. So that we have this kind of chain from like uploader to where it is and what it was signed for. And the data needs to be verified on the server. And the other things so this is always like an in toto statement, and that goes a little deep, but the other thing that we always validate is the subject. So the file name of the Conda package and the SHA hash of the Conda package. And then what this actually does is that on our website, what you will get is you will get a little badge and an attestation when you upload the attestation. And this is kind of a feature that we haven't really like talked about before, at least not publicly. But we already have rolled it out. So if you want to be an early adopter, you can talk to us and we'll explain you how to use it. But the attestation, basically, this one is stored on the transparency log from the public good instance of SigStore on SigStore.dev. And basically, when we run the pipeline in GitHub Actions, which is actually also linked here, we in the pipeline, we first build the package with Rattler build, and then we run the attest action. And this one will create an attestation using, GitHub has that built in, and it will store the attestation on the public good SigStore instance, which is what I'm showing here. And this one also has all of these data again of what was signed, what action was used, etc., etc. And then we upload the package. And what this does is it's uploading here the Conda file, and then it includes this attestation, which was created before by the GitHub action. And if you would look at the source code for this one actually is an output of the previous attest action. So that's what we are doing here. What we really want to achieve is that Conda packages will be naturally signed using SigStore. And we want to verify these signatures on the server. We later also want to verify these signatures on the client side so that you know, like, you basically then, based on this information, what it gives you is like cryptographic proof that this package was created and signed by this GitHub action, which includes like, for example, the username here. So if that was a company, you could say, okay, I only want to trust packages that were created by this GitHub account. And SigStore is more and more becoming a standard in the package management ecosystem. And for example, PyPI again already has support for SigStore. And so in that sense, we're also catching up here. We are still like this step is basically the next step in terms of us rolling this out and really making it available and be more vocal about it. Because the problem that we're trying to solve with that step is that right now when we run this action, we also have to give a predicate type and a predicate. And this predicate is currently something like example.com that it's also completely empty. So it being completely empty is not really the problem, but it's saying example.com is kind of not great. You could put anything you want in here. It doesn't matter right now, but we want it to matter. And that's why we want to come up with a schema that we publish. and the predicate. And even though that might not be the predicate that we use in the long run, because we might also use something like salsa, which is other like more complicated method of basically creating one of these predicates. So that might be something that we use in the future, but for now, we would like to have something simple that we can verify and validate and that we can use in the meantime. So that's what this last step is about. If you're interested in software supply chain security, if you have any opinions on SigStore or package signing, then please talk to us and help us design this so that it will be great. And this goes in general for the whole SEP process and the Conda community. If you are interested in any way in helping out or contributing or collaborating and driving the Conda ecosystem forward, then we would love to have you in the community. And this concludes my presentation.
Thanks, Wolf. I will stop the stream now and make this public good, and see you next time.
Awesome.
Okay, stream is ended.
Also, hello, Mr. Bass.